Yes, I think I have started the recording. Let me see. I'm sharing this screen. You can see my screen, right? Yes, thanks. If we don't have any question for the videos and for the A2 assignment brief, let's start the modeling. I hope you can start Monde as well and follow my steps. And after a few steps, I will give you like around 3 minutes to catch up. So I hope everyone can keep the same pace as me, so we can have a small model after, at least after this class. Let's start. Because our group has Melbourne, so I'm using Melbourne as the example. You can find the instruction in Moodle. There is a week for Monde modeling instruction. First find it, Moodle. Yeah, if you have Envi-met Lite installed, you can open Envi-met Lite. If you don't have it, you can please have the virtual lab ready so we can start now. Let's see. Yeah, this is the tutorial guide for the modeling, and you can go through it a little bit. The first step, let's open Envi-met headquarter. If you have any question, you can just interrupt and unmute yourself. Okay. Envi-met, we have this Envi-met headquarter. We have two modeling systems, as I mentioned in week 2. One is called Space and the other is called Monde. In Space, we have the base map. We import the base map and then we follow the footprint of every building, every vegetation and the road to do the modeling. It's easy, but it's time consuming. And that is why we recommend, if you haven't started, if you haven't built your model in Spaces, we highly recommend you to use Monde. And let's start clicking. Yep, have Monde opened. Yeah, I hope you can do exactly the same as I am doing. And if you can't catch up, I'm too quick, you can interrupt me at any time.
How about the week 4 tutorial slide? You feel it's difficult for you to follow every
step? This is the very beginning interface of Monde. And what we need to do is to, let's see, the first step. I will drag this to the other screen and you can have it download it in your own computer. The first step is that find the location of the center of your site. So we all have Melbourne site. The center of our site is called this cafe. You can just type in this name and let's search for the center. Word setup, find location. It is called lobby forest.
First,
remember, we will use Google, not the geonames. We will use google.com. Search.
We have already downloaded this software.
Yeah, this is the right address. We will select it and click OK. Then you can double check the longitude and latitude, whether it is the right position of what you want. So let me double check. The longitude is 144.95, 144.95, latitude minus 37.8, 37.8. That's totally correct. Let's proceed. Because we don't want a very large map, our site is only around 500 by 500 meters. So we will just cut 1,000 by 1,000.
Visualize output.
Yeah. We won't need a very large map. After we set up everything,
space.
Let's
Let's
create empty project map.
And you can choose to build your model 1 block by 1 block in space. Or you
I will give you 1 minute to finish this step. This is called a georeferenced map. Our map now is not just a blank map, it has the georeferenced location. So afterwards, we will directly get the map from Google Map.
You have create your model, you need to use this Envi-met guide to have you set up your simulation, which have to identify which day of the year you want to simulate, or how long the peak period you want to simulate, and what is the boundary condition, initial condition.
If you get stuck, you can just unmute yourself and let me know.
The environment, weather condition of the simulation period, you have to specify that in the Envi guide, and then we use Envi-core, which is a physical engine, will help you calculate the physics in your model. And then, if you want to add some comfort features, you can. And
please also let me know when we can proceed. If you have everything ready, please let me know. We will proceed.
And I will teach you how to use Monde to create your first domain. If you click space.
Can we proceed? Is your georeferenced map ready?
Yes. It doesn't
yes.
matter.
Okay.
For
good.
The modeling.
The next step is to get OSM environment.
You can use
Click Get OSM environment, and it will obtain data directly from
For
OpenStreetMap.
the final calculation, you better use a scientific version.
Yeah, and then you will have this
because a light
interface.
version. Yeah. You can create your model in your own computer and send it to the lab computers to let it calculate, because in the lab
in this interface, we have some predefined categories. It contains the information of water and building. What we want from Monde for the time being is just building. So let's untick water and select building.
50 by 40.
From OpenStreetMap, what we have for buildings, we have these categories of buildings. We have retail, we have office, we have commercial. We just accept all tag values to include all types of buildings. And then for each type of the building, what information do we need? We first need the building name, the building type, the building name, and building levels, how many levels the building have, and building height. This is the most important information we need to get from OpenStreetMap. Remember, you have ticked the building height. And for others, it's totally up to you. Yeah, I don't think they are essential information. Once we have set up everything, let's test this setting. Yeah, if you zoom in, you can only zoom in by clicking this, or you can't just use some shortcuts, because we don't have any shortcuts for zoom in here.
Workspace first.
Yeah, let's clear up and do it again. Test settings, and by testing settings, you can see using this kind of rules, what polygons are you getting? You are getting, for example, test. These are all the building footprint we want. Remember, it should be polygon here, not points, not lines. Should be polygon, because we want enclosed building footprint. If you test settings and all building footprints are included, And remember to untick, remove
create
test
workspace
layer
project
and
first to
geometry
Envi-met,
and get finish.
You may
Yes,
have the
we want
risk
to proceed.
To make the database.
Yeah, then you will
using
have
the
this
wrong
OpenStreetMap.
database.
Center
For
is
example,
our
you want
center.
to
The
try,
center we just
increasing
inputted
the
that
reflectivity
cafe
of-
and with the
of
1000 by
concrete.
1000
But you add it
range.
in the system database. The next time, your model will load the profile, concrete profile from system database, and you didn't aware of that.
And you can
have
see
changed
there
some,
is
but
some
next
building
time,
layers
the system will,
appearing under the GIS category.
will recover
And
it
if you
to
want to
its
check what is
default.
included,
So you have
you
to
come to layers, you can
if you do
show and
anything,
hide
go to
and see if you hide this one. And let's see what is
first
included in the
create
first layer.
workspace that's
Yeah,
creating
or
one.
building footprints.
Here you
That should be fine.
change workspace.
Yeah, then this layer, we can work on it afterwards. Yeah, I'll give you 1 minute to finish this importing. And then we will proceed.
Now you have a new workspace, and this is where it located. And you can create a new project under it. That's the name of this workspace. Your project folder. And then you apply project settings. Now you have a project upgrade setting.
Yep, everything all right?
First project created, and you can go to a folder. Now you can see this. Now you have this project info.
Do we have any questions? Can we proceed?
Monde is G software.
Guys, you can talk to me. So I'm able to know whether we can proceed or not.
This is a location for our groups.
Yeah, maybe we can ask some volunteers to share the screen and let me check whether everything is all right.
From that location.
If you wish.
Here go to work setup.
You can hear me, right?
Yeah.
Thanks. If you finish, you can just unmute yourself, say, I'm finished, I finished, and we can proceed.
Here, but if you know it's time zone and time zone only.
Yeah, I think we can.
Type everything here.
Yeah, thanks.
The other way is.
Once we have this OpenStreetMap, it covers 1000 by 1000, and with our site center being the center of this map, so we can proceed. Let's check what is the next step. For buildings, remember to select building height, that's fine, tap settings. And because this data is obtained from OpenStreetMap and the accuracy, we should double check the accuracy. And also for some buildings, I'm sure it doesn't have the information of the building height. So it's not very comprehensive. Let's check. How do you check? You come to this layer, right click, layer properties.
If the first one
We will
show
going
it,
to
sometimes it
color
has
different
no
buildings
difference.
based on their building height. Modify
Use one which can show the result.
color by value and use attribute select
Let's compare
building height. Yeah, once it's done, click OK and modify layer.
Location of assignment tree. And
Now you
location
have
is
different building heights in different colors.
slightly different.
And let's check. Let's
It's
zoom
not the actual
in a
location
little
point,
bit
so
and check.
we need to
If you press Shift and
expand
the
our
mid
map
button
our
of the
more
mouse, you
in
can
order to
move.
make sure
It's
the
Shift
area we
and
are
mid
interested
button,
in
middle button
is
of the
covered.
mouse. Shift and middle button together, you can move. But to zoom in and zoom out, this is the only way to zoom in and zoom out.
Not to cover
If you want to check the specific information
And
for
there's
one
two way
building,
of the replication.
under this
Two ways
layer,
to use the reference location. First is
click
use the
this
center
building
map. In our
and
case,
click
we have
here.
we have to use the
This is
location
an
information for the
information
center
icon,
of the section.
and
So
you
we-
will
we choose
see
this center of the map and
the
type
building belongs to
type
university,
another
and it's the law school
But in
of the
some other
University of
cases,
Melbourne, and it has the building
if
height
make
of
it
16
for the
meters.
Bottom left, which is
So with the 16 meters height, it has been colored to dark
which
blue.
is
But for all the buildings without any
this
color,
location.
these white buildings, if you check the building information, it doesn't have the height. It doesn't have any height information. So these are buildings we need to complete. Yep. If you double check for all the white buildings, if we don't have the information of building height.
We haven't added data to it. That's
Right. So the next step to do is to assign a building height to every building. So they are now.
Hi,
they-
sorry to interrupt.
Yeah.
I'm not getting the heights for the building. I mean, it's all gray right now.
If you share the screen, let me stop sharing for a moment.
Yeah.
And before doing anything, you need to complete this box. And let's
If
go
you share the
to
screen and let me check.
and select what
Yeah. Can you see?
attribute we want to add.
Yes,
Or this is the one.
Okay. So like I've
right
selected
click,
this layer properties. And
modify.
This is right.
Yeah,
So I'll click OK, and then if I click on modify layer, so it's
if you come to the OSM buildings, because you have two OSM buildings, right?
yeah.
If you hide one of them, if you hide the one, if you hide this
Okay.
one,
So how do I
layers,
hide this? I mean,
yeah, layers, the top,
okay. Yeah.
yeah, the top ribbon, you have layers. On the layers, you
And
hide.
this.
Yeah, hide. Yeah, if you hide this one, you can't see any difference. That means the main
Yeah.
building
So I'll
information,
hide the second one.
the main building information should be contained in the second one. If you show, yeah, click.
Okay. Yeah. Got it.
Oh yeah,
Okay.
because
Yeah.
they
Thank you.
overlap.
Yeah. Understood. Okay.
Your center is the cafe I just shown, because I can see a larger range of the buildings, but that's fine. You can adjust afterwards. You understand? Because we don't want that large, the map, because that will be very slow for us to zoom in and zoom out. We just want the center of this map to be our center of the site, and then with the minimum range of the map. So it will be very quick.
Okay.
Yeah, that's my point. Let's
Yeah.
proceed. Yeah. So now we have to assign the building information, the building height information to every building that doesn't have such information. We come to this building. We come to this layer, and let's zoom in a little bit. For example, this building, the right way for you to assign a building is to first check the building height, at least how many levels this building has in Google Street View. That's easy, but that's kind of time-consuming. I won't do that. I'll just assign some random values. But in your case, you need to check, for example, one of your groupmates is responsible for check the building height for every building, and then the other is responsible for assign this value to this layer. Okay. under so we're actually editing the information of this layer. So select this layer, edit building.
We all have the height information.
Yeah, you will have this dialog.
Excuse me, G. We can't see a screen at the moment.
Oh, sorry. Thanks for reminding. Stop sharing. I didn't share back. Let's have a look. Yeah, you can see it now, right?
Yeah, we can.
Yeah, thanks. So now we want to assign the building information, building height information to every building. That is by editing this layer. Select this layer and edit.
After my demonstration,
You will see this dialog. What we need to do is to, because we already have the polygons, we don't need to do the footprint one by one. You just select either of the building and add, for example, this building you find in Google Street View, it has the height of around, for example, 6 levels. We just assume it to be 18 meters
this is not
and
problem.
apply.
Otherwise, later they will crop the map.
Yeah. And then we select the other one, another building.
And
We assign the height to be, for example, 20.
in
In your case, you need to check Google Street View and find approximate, accurate building height. I'll just assign the random values to save time. Apply, and the other one, for example, is 6 meters, and apply. Because we already have the footprint, we don't need to have any reference. We don't need to draw the footprint anymore.
ask
10
you
meters,
to
for
add
example.
the numbers for each attribute of buildings like
14.
the height.
I'm just doing this small part. I won't do the overall. 56 is too much. Let's just add 30.
Just to the same value that the data we get.
I'll quickly do the rest of this part.
Sorry, can I ask again, where are these data from?
Google Street View. Let me show you. For example,
Now we have
we find
our model.
our site is located in University of Melbourne.
But now our
And you
building
find
is
maps.
actually the same height. If you go to the height, let's see here, height,
Our site, I think it's approximately here. Let me double check. University of Melbourne, I think is that right? Yeah, it's around here. Right? This is our
Yeah.
site. Yeah, approximately. How we can do that? Come to 3D. Yeah, you can see, for example, this building 1, 2, 3, 4, 5 levels. So it should be approximately 20 meters, I think. It's a commercial building. 3 to 4 meters per level, and then you do the calculation.
Okay.
Yeah.
So we don't get the exact data, right?
Because we have the limit from OpenStreetMap. For some of the buildings, those original one, let me show you. They come originally with a height, building height from OpenStreetMap. We don't need to do that part, but for all the buildings that doesn't have such information, we have to manually assign the height value.
Okay.
It depends, because for Sydney, we have a very mature data set, and a lot of buildings, they already have the building height information. But for Brisbane, it's another case. None of the building has any building height information. So Melbourne is actually between these two, but we still have to add a lot.
Okay.
Yeah.
out.
Yeah, I won't do all of them. I'll just show you how to do that. After we assign the values of building height to all the buildings, we need to finish editing layer. Always remember to finish editing. Otherwise, even you close this window, you can't do anything, right? Remember to finish editing layer and close this window. Then what we need to do is to, because as you have noticed, all the polygons here, the building information, they are under GIS category. They are not under modeling category. That means they are just polygon information. They are not modeling information. What we need to do is to select this layer and right click, export to modeling layer. And it will, this is very important, please pay attention. Modeling layer type is building because we are modeling the buildings using the polygons. And there will be assigned attributes. This dialog is a bridge between the polygon and the building. So this will assign, for example, it asks for building top. And what are we going to provide for the building top? We use assign values using attribute data. We are going to provide all the building height information to be the building top in the modeling layer. Is that clear? Polygon has the building has the height information, but in the modeling layer, the building in modeling layer, they need building top. We are going to match all the building height with the building top and assign, for example, building bottom, because we don't have any topography, we just assign 0 to this building bottom. Apply. We didn't apply this, the building height. Yeah, and for building name, we assign the building name. Apply. And for building wall material, this is another, because we just watched the videos for a database, right? We have a lot of wall materials available, and they all have an ID. If you remember, it's 6-digit, for 00001C or this kind of thing. If you want to assign, automatically assign the building, a building material to the building walls, you can first check what is the code of the material you want to assign, and then type it in here. It will be assigned to all the building materials. For example, let's check, we want concrete. Let's open the database manager. And let's check what is the code for concrete. Building material wall. Yeah, this is, we just use the system wall. Later, if you want to assign, for example, what is the reflectivity? 0.2 reflectivity and 0.8 absorption. You have to define your own customized material. We just find one in the database. For example, lightweight 0100C2.
Slightly larger.
0100C2. Yeah, then it will automatically assign this material to all the building wall and apply. For building roof, we are using the same material. 0C2. Yeah. And for roof greening, facade greening, we don't have any for the moment, so we'll just leave it blank. Buildings, modeling layer. Yeah, we have matched everything. Let's click export to layer. Yeah, now you can see under the modeling, we have a layer of the model.
Now we have created.
Yeah, I'll pause for like 3 minutes for any question you have and for you to catch up. You don't need to do a lot of building height. You just assign some random ones, learn how to do it, and then export to the modeling layer.
Required size it's not the original area is not northwards. It's a bit it tilted to the east, so we have to do that to make sure it is covered in the whole rectangle. And we can create this model. And when I show you other features to add the topography, we don't ask you to do that in the assignment, but I will do it very simple. Have you have when you have got these maps, you just go to get topography. So you have a layer of topography. Now we can create model from it. On the map, that's what features are included in your final model. You need to select. We have created our interest areas and select this one. And you can adjust your model size here. I use the horizontal resolution of 2 because you can see because its size is about 380 and multiply with 530. So we use the resolution of 2.
Everything good?
Get about 193 degrees plus multiply with 2.
Can we go on?
That's the big.
Yeah, you can go on.
Yeah, thanks. After we have the modeling layer of our buildings, what we need to do is to create an area of interest. We won't export all of the map to Envi-met. We're just cutting like a small portion. It's called sub area. Come to sub area and edit sub area. Create a sub area. You can't do any rotation or adjusting when doing the creation, but we can do it later. For example, our side, I think it's approximately here.
Two options allow you to
Add
have a
element.
better
Yeah, this would be our area of
noise.
interest
I will show you
and
different
finish.
space, how it works.
After we have building footprint, building height, and this area of interest, we can proceed creating Envi-met model.
11 meters resolution.
For sure, we don't want
It's very broken.
topography, and we want this new area to be the model domain. And if you want to adjust, for example, let me just, never mind. Adjust, you can only adjust like rotate or move or scale this new area by adjusting here. You will have this small panel, adjust. Yep, you will have this adjustment panel. But before doing that, I would highly encourage you to save your model because based on my experience, this Monde file can crash easily. You will save as my word. It's called, for example, test or because when you're doing it, when you're exporting, it can crash very easily. So I recommend you to save before
Before doing anything,
export.
you need to
Save.
check
Okay.
select project.
Now
option.
we are ready to go. We
You have to select
go back to
this,
analyze,
have to
create
select
Envi-met
the
model,
project you have just
onto
created.
topography, select
If
new
your-
area, and let's adjust.
If your project
We want to rotate it
to
be parallel,
You have to change
right?
it. to a
Yeah.
specific
And
project.
then we want to move it a little bit.
That's the first thing you need to make sure.
Yeah, if
every
you
time
want to make it
open
the
this
size more
software,
accurate, you
then
can
you
adjust
open
the
it
X and
every
Y
time. Just
scale, maybe make it shorter or longer. Yeah, I think it's pretty much. Yeah, let's click update and okay. Let's have a look. Oh, we need to extend a little bit in this direction. Just looking.
And then because we use a resolution 11 meters, so it, our buildings just look like
extend
block.
a little
It
bit.
doesn't have any details.
Yeah, that's all I understand. Right. And
You
okay.
can see our model.
And here it's very important. This is the output settings. For this new area, whatever is covered in this area would be exported into Envi-met. And this, the size of this new area would be the size of our Envi-met domain. So it's very important to set everything correctly here. And we have the resolution setting here. Horizontal resolution for the time being is 2 meters. That means every grid will have the size of 2 meters by 2 meters in X and Y. 2 meters is a very high resolution. And you can see here we have X and Y being 300 by 200 something. Remember that in the light version, we have the limit of the grid size 50 by 50 by 40. So X is 50, Y is 50, and Z is 40. So if you use 2, it's impossible to be fitted into light version, but it can be fitted into the scientific version in our virtual lab. But we don't recommend 2 as it's too high, the resolution. It will consume a lot of time. Let me give you an example about. Yeah, this is a 7 meters resolution. X and Y are both 7 meters resolution, and the buildings look like this. And this is a resolution of 5 meters. So it's more like refined, the buildings. But it will have definitely, for example, you have here 120 by 90 great quantity, but here you only have 48 by 33. This one can be fitted into light version, but this one cannot. Yeah, remember that the higher the resolution, the smaller the grid size, but the more time it will consume.
That will take a lot of time.
Yeah.
Even you have restricted your model to 50 multiply.
So in assignment 2, I think we have some recommendations here.
A lot of time.
Assignment 2. Assignment 2, we have the recommended resolution X and Y being 5 to 7 meters, and Z direction is 3 meters. So let's just use 7 for time being.
We don't want to lose too much.
7, so we have 90 by 66. That's fine. It still cannot be fitted into light version. 3 and the highest building we have. If you have the highest building higher than 30 meters, set its height to be 30 meters. So 30 meters should be the highest value in our site. If 30 is the highest value, we just need to have around 60. The total size of Z grade should be 30. That would be fine. And this DZ of the lowest grade and also telescoping. Do you know what are they?
We allocate more grades on the bottom.
Have you do you remember what is the meaning of these two when you are watching the videos?
You can see here, this is an
the DZ of the lowest grid box is split into 5 subcells. What does it mean?
If we have 2 buildings like this,
if you check here, this is my model, and I have ticked. I have used a DZ of the lowest grade to be split into 5 subcells because we have some grass here. If the lowest grade of the Z direction also has the height of 3 meters, which is the grid size, that means our grade our
That's
grass
one-
here will have the height of at least
scale
3
effect.
meters because that is the smallest size of the grid. But if we
This is telescoping
split
factor.
it into
If you
5
use
subcells, that
it
means the
allows
grid,
you- allows
the
you
height
to
of the grass would be around
scale your
0.6,
Z
right?
grid like
Which is
that.
more realistic. That is
For
our
example, the first
consideration of
grid
why
is 1
dividing
meter.
this
If you
the
use
lowest
telescoping
grade to be
factor,
5
like
subcells.
10%, the next
Does it
one
make sense?
We'll multiply with 110, and the next is
Do I need to explain again? Does it make sense?
Yeah, it makes
that's
sense.
how this
Thanks.
telescoping factor works.
This is
Each,
just for the
each
sake
grid
of
will-
the grass.
will la-
Otherwise,
will
we
larger
won't need to
than-
divide
than
into
the
5
previous grid by
subcells.
10%.
And this telescoping, DZ increases
another
with
option.
height. It has a factor. We usually set it to be 10%. Start telescoping after height of 30. What does it mean? It means because our Z direction, the domain size is at least twice the height of the highest building. That means, for example, if the highest building is 30 meters, we have a domain size vertically of 60 meters. And from 30 meters to 60 meters, we don't have any building actually in that space. We are just leaving the space to facilitate like the wind circulation, that kind of thing. So that doesn't need to be analyzed very in detail. That is why we start the telescoping after the height of the highest building, just to make the simulation faster and without losing a lot of details.
The height of this
This is the descent and telescope.
at least 3 times of the height.
After setting
For example,
all the
if our
resolution,
highest building
so
is
once you
this
have this Monde created here, we saved as the Monde file. If you want to change the resolution, you just need to do the export again. If you want to change it to 5, you just export again to a model of resolution 5. You want to keep 7, just create the model. The resolution is actually adjustable if you are using Monde. But if you're using space, you set up the resolution at the very beginning, you can't modify it anymore. So this is the advantage of using Monde.
60
Let's see
meters
buildings,
away from your building.
save
address.
to the
Reason
space file.
you need to give the green
Let's
space
just save and
low
stop
in
desktop.
this area.
What is the date?
Otherwise, it
10th
may
of October.
cause some unwanted
Save.
turbulence in this area.
Close and save.
Oh, okay. And there is how to
Yeah,
check. your
Once we
model
have
values.
everything done in Monde, let's get back to
Here, after
spaces.
you have imported your model here,
Envi-met,
you want to know
spaces.
the actual Z grid settings
Yeah.
and
I will wait
whether your
for
model
2
has
more
these
minutes
requirements. You go to this model
to let
inspector.
you finish. And then
Here.
we will start the spaces part.
It gives you the resolution and it tells you on Z level what is the height of each Z grade and what is highest grade. In my model, my highest level is 70th grade, is pretty enough. And it will give you some check result. Please check this to modify your model until there's no warnings here, as it says space between buildings model further be larger space. So I need to give more space to make my model wider. And here it allows you to apply different telescoping factors, and it immediately shows the different values in this window, and you can adjust your telescoping factor here. I think that's enough. And then I think you have already watched the video. The space is a pretty easy model. That's how you do it. That's
Do
how
we
you
have
do
the
this
model exported successfully?
I think that's.
I think we can start
enough
the
for
space bar, right?
Demonstration. Now,
If you open
we can start
space,
to practice.
You're
And
going
if
to
you have
select the
questions,
model you
you can
just
start to
exported.
ask me.
Open area
solve
input
it.
file. I have exported some smaller models because to fit into the light version, because what I'm using now is the light version actually. I will choose one of the smaller models because as you remember, when we exported, we chose like this one already have the vegetation.
There was a student asking me about a question.
That's fine. We will
Just
choose the
now,
one we just
I have
exported.
submit.
Open area input file, desktop, and this is the one we just created. Let's go to 3D and have a look. Yeah, these are the buildings we just created and exported into Envi-met. So for the building part, we no longer need to do anything. Once we have all the building height assigned to every building, we don't need to do anything in Envi-met anymore. We have the footprint, we have the height, all very accurate. The only thing we need to do is to put the vegetations, trees, road, and the land surface. I would recommend you to, for example, let's check our site. Yeah, if you check here, you can see the majority of this site, I think it's concrete, right? The road, concrete. Yeah, let's just first select the majority of material and apply to the land surface. Soil and surface, system profile, and let's use natural surface, not natural surface, roads and paint. Concrete pavement gray or light, it doesn't matter. We select this material and we choose apply selected profile to all grids. Yeah, now you can see we have applied concrete to all our land surface. The only thing we need to do is that if there are minority of, for example, earth, soil, or vegetation, we just modify on this basis. We come to vegetation, we change to the plan view. Zooming a little bit. Yeah, you can see the building height. This is the building height, the value here. Vegetation, we're going to do the grass. First, grass. What is the height? It doesn't matter. Dense.
Maybe you close it.
You have to be very clear, very careful when you're drawing the grass. It's like once you, for example, it overlap with the building. Let's see what will it look like. It will be put on the building top. We absolutely don't want this, right? So you have to be very careful when you're drawing the grid.
Headquarters. Go to headquarters first.
How can you delete that one? There is no Control Z. There's no Control Z in Envi-met. Please really pay attention. You can't just go back, Control Z and go back. The only thing you can do to delete this cell is coming to, there is a tool for selection. Click this one to put it on the corner, this one, the other corner. And delete. Delete the simple vegetation here. Click selected area. Yes, and deselect. So it's very complicated. So I would recommend you carefully join everything in spaces. Let's do some grass. Yeah, if you
find the location.
Yeah. For the other spaces, we can do it quicker because it doesn't have any interaction with the building edge. And for the building boundary, you have to be extremely careful. Yep.
Great.
And then once we have all the grass assigned, let's add some plants, 3D plants. For example, trees, palm trees. This is just a general tree. We put it here.
Yeah, you might have some.
You can check roughly where the trees are located in the real site, but don't put too many trees. For example, for this building block, the large building block, we just put like 3 or 4 trees. That would be enough. Otherwise, our simulation would be much slower. And if you put the trees, let's have a look how they look like.
Yeah.
You can press Control and the middle button of the mouse to orbit. Control and middle button.
I suggest you to, because Monde allows you to.
You can see the trees are actually floating in the air.
Export your
Yeah,
space
because
file.
they
So
this
you can export a low
orbit
resolution
a little bit.
space file to your own computer and run it on your own computer.
Because this actually represents the canopy of the tree. It doesn't contain the root or some other components. It's just representing the canopy of the tree. So it's floating in the air, and this, don't worry about that. It's not a mistake. Let's see what about other kinds of trees.
That would be the standard procedure.
Yeah, they have some of the trees, they have different canopies. Let's have here. For example, some low trees. Let's have a look whether there is any difference. Yeah, you can see some of the trees, they have the canopy like wider. Some of the trees is more compact. Yeah, it depends on what kind of trees you have in the real site. You can choose different types of trees. Yeah, once we have the trees, have the grass, we can paint the road.
Yes. That's unfortunate for Brisbane precinct.
But I think the road is concrete and we don't need to
directly
do a lot of work. Let me double check.
So that's why our precinct is smaller than others. That's a
yeah, we have some trees. All the rest, I think they are concrete. Am I right? Yeah, we don't have any soil.
In space, you can modify your model.
Yeah, I don't think we need to put any soil here. But if necessary, I'll show you how.
Everything is
soil and surface.
You can add more features like.
So now all of them are this pavement light, concrete pavement light. If you want to have some soil, you can select, for example, the loamy soil and
add soil,
put it in a boundary.
You get it?
If you want to see the reference lines of the building, you untick the display surface with color. Yes, it will just display names and help you model. For example, this part we assign to be soil. This is the way to paint. And let's double check. Yeah, we have soil and then we have all the rest to be concrete. This is pretty much we have in the conceptual model. And we require
you can do it here. Let's do it here.
In the assignment brief to assign glazing to only 1 or 2 buildings. Assign fully glazed facade to only 1 or 2 buildings, and don't need to assign the details for other buildings. Let me show you how. We need to convert to 3D model because now it's called 2.5D. But remember, once you convert it to 3D and add some elements, and then you convert back, your details will be lost. So this should be the very last step to add the details. Convert to full 3D. This cannot be converted without potential loss of data.
Compare with
yes,
the in the slide, and you can
now
start to allocate
it's 3D detailed model, and we use buildings, set individual segments, and choose. If you hover over here, you can see apply wall material to
First,
buildings,
remember,
and
first you
here
need to
it's apply
export-
roof material to
export
buildings. So
a
they're
building
different.
layer.
This is
Now,
wall and this
all
is
these
roof.
things are just polygons.
For walls, we
You
want
need to
some
make
glass
it to become
in the facade.
buildings.
Let's see, glass. For the wall, for the roof, it doesn't matter.
Right click
see.
on polygon on the left.
This
And close
is
this
the way
dialog.
to
Close
create
this
a
dialog.
glazed facade.
Right click. Export modeling layer. Yes.
Yeah, if you want to set the whole surface to
first
be
select type,
glazing,
buildings.
you choose this option.
Buildings. Yes.
Let's say
And
the
remember,
materials.
what I have said.
Yeah.
First, allocate a fixed value. You can see at the bottom, there's a sign value.
It's just applied to the whole grid
Assign
in different
maybe 10, or
options.
whatever number you want. And apply.
Select building.
Apply. And go to building names. Yeah, bottom for
Import it a
0.
little bit.
Apply. And then name. Name. Go
Set
to building
home
attribute.
to be
Use data.
glass.
We have
and
name
deselect.
input. Yeah. Select. You can't do that because you can't do that because you didn't save the test layer. Please go to the OSM environment again.
And that's all right. I think we can just use the set individual segment because the whole surface is not recognized in this specific building. And add. Yeah, we use add to change the facade to glazing. Yeah, you only need to do it for several buildings. You find some windows, for
You don't need to
example,
do that.
on level
That's-
2,
that-
level
that-
3,
that
find
was
some
a-
windows and apply to 1 or 2 buildings. That would be enough. Don't need to do it for all buildings. And after we have, let's see, we have
Buildings.
plant,
Building
vegetations,
level,
trees, buildings, roads,
test this
and
setting.
soil.
Click test this
I
setting.
think it's complete for our teaching
Okay,
purpose.
that's-
And let's
that's-
go to
Okay,
3D.
that's a layer. Yeah. That doesn't matter if we want to use that.
And then you can save it to
Okay, finish.
save model
Yeah,
as.
finish it now.
This would be the space file.
Then the same, go to, not this one, yeah, where's that building?
Desktop.
The one.
Yes.
Which one? This one.
I will pause for 5 minutes for
Select
you to
type
catch up
building.
and
Type,
try
otherwise
to
you
paint some of the vegetations yourself and see
select type.
whether you can control it or not.
This is not
Is everything going well? This painting in Envi-met space is not easy to control. You have to familiarize yourself with it for a couple of days in order to model very accurately. Yeah, might try yourself a little bit, especially this this grass and also this facade. If we convert back to conceptual design, you can see every detail we added. See,
You have already selected this. You can look
Convert
at the
to
right
conceptual
corner.
design. Yes.
Up right corner. You have already selected the project.
Yeah, you can see every detail we created for the building facade will be lost. Once you convert back to detailed design, you have to do it again. So convert to detailed design and add the details would always be the very last step.
Untick those two boxes. Click
Do we have any
and
question?
click layers. Click modeling on power sample. And click
Yeah,
layers.
assuming that we have finished this space
No,
file,
not
let's
here.
close. We have saved and let's close it. Let's see how we can do the simulation quickly. By the beginning of next week's course, I hope that everyone can has the building model ready, including the buildings, the roads, the vegetation and trees. I hope you can have the building ready, and then next week we will explain the logic of this simulation, how this microclimate simulation is conducted, and why are we setting the boundary conditions and those kind of things. Yeah, you don't need to hurry about the simulation, but I will quickly show you how to do the simulation. And at headquarters, we come to Envi-guide.
On the bar, on the layer bar, displays style. Layer bar.
Where is it?
Yes. This one. And color by value.
Yep.
Choose color by
Come
value.
to Envi-guide.
Use
Oh, it's in the
attribute
other screen.
Yes. Then OK. And
You should first have a project, run project manager, and create a project. I have a project, and it has to be saved in the workspace. If you want to change the workspace, just choose a new folder. So everything, the modeling file, the simulation file, and also the output will be saved under this project folder. Yeah, make sure you have everything here. This is the project, and then we will have to set up the simulation. For example, we start from the new, and we want to simulate. We will give you the weather data next week.
Yeah.
And detailed instructions. Don't
Check the height of each building in the precinct. Yes.
The current we have, whatever. Yes, we only want the 2 p.m. situation, but we will start
Okay, maybe
from
you
1
can-
p.m.
you can,
and we will explain why
Stop
next
sharing
week.
and start to do
Because
that work.
the software needs some
Maybe
time to
others may have
predict.
some questions. If you have encountered questions, you can ask.
Let's see, start from 1 p.m. and for 2 hours. New simulation, we call it 8th of October.
And do you have other questions, guys?
Next. And we will use, this is the space file we just created. And we select the space file. If we put it under the folder, it will automatically appear here. Next, intermediate. We want to use our own weather data. Next, this is the initial meteorological condition. We will explain next week about how to set this initial condition. And this is the temperature. You have the temperature of one day. You type in, for example, 25, or you just copy paste from Excel, 26, whatever, and just type in everything randomly. And you refresh. You will have different temperature profile and relative humidity profile. You set up here and then click OK and next. We don't need those settings. And intermediate. This is the simulation file. This is the space file. This is the start date. Running time is 2 hours. And simple force. Next. Save and start the simulation now. And this would be a simulation file. We will call it October 8th. Save and finish. Yes. We already said. And then you will have this popped up window. It's saying, it's reminding you that I'm using the light version and the limit of the grid size is 50 by 50 by 40. That's fine. The file we are choosing is within this limit. Let's choose the project. It's loading the project. Yep. And now we load simulation. We will load the file we just created and open. Yep. And if you click wrong, it will start the simulation process. And later you can see there will be a progress bar here in the corner. And yesterday I run for 50 by 50 by 40. It cost me around 50 minutes. When you finalize, you will see it has reached 100%. But we need to check because different settings will lead to different simulation time. It's not quick because the time step is only 1 minute. Let me show you what you will get if the simulation is finalized. If the simulation is finalized, what you will get is under, mine is under C disk Envi-met. This is the output of my previous simulation. You will have different folders, and these are all the output file. And then we will use another module called Leonardo to analyze this kind of output files. Yeah, that's the content for another week. I think next week. Yeah, this is the whole process, and it's not quick. For the current one, it might take around 1 hour to 2. So that's why we recommend you to set your computer to be never sleep in order to not interrupt the simulation process. Yeah, that's pretty much about today's content. And I hope you can spend some time after the class to finish the modeling. And from next week, we will introduce the simulation and we will start analyzing the results. If you have any question, we can use this very last 10 minutes to have a discussion.
Do we need to get the temperature data ready by next week as well?
We will give you the temperature data.
Oh, I
We
mean,
will, sorry.
just get the file ready in Envi-met. I mean,
Uh,
we just talked about before, like the 15-minute one.
by next week, you only need to have the space file ready. The space file means the one from, I close it, from spaces. That is the model. You only need to have that part ready. And we will give you the temperature. We will instruct you about what temperature you should use because we still need to spend some time, our tutors, to test whether the simple force and full force both work fine in the lab computers. And we will let you know next week about simulation details. But by the start of next week, next week's class, please have the model ready.
Yeah. Oh,
Yes.
good. Thank you.
I will stop the recording.